Have you ever tried to send data over the internet, read an image file, or work with encryption in Python and bumped into something called bytes? If it confused you, don't worry. By the end of this tutorial, bytes will make total sense. Welcome to Python Bytes Explained, where we break down binary data step by step, from strings to sockets. Let's get started. Before we write any code, let's understand what a byte actually is. A byte is just a small unit of data made up of 8 bits, ones and zeros. Every file on your computer, whether it's a photo, video, or document, is stored as a long chain of bytes under the hood. In Python, the bytes type lets you work directly with that raw binary data. Think of it like this. A regular Python string stores human-readable text like the word hello, while a Python bytes object stores the binary version of that same data. They look similar, but they're very different things. Watch as we visualize a byte as 8 individual bits, and notice how Python treats strings and bytes as completely separate types. There are 3 simple ways to create a bytes object in Python. Method 1 is the quickest. Just slap a lowercase b in front of any string literal, and Python treats it as bytes. Method 2 uses the bytes constructor with a string and an explicit encoding. UTF-8 is the most common encoding you'll use, and it supports almost every character in every language. Method 3 might surprise you. You can create bytes from a list of numbers. Wait, numbers turned into letters? Yes, because underneath every character is a number. 72 is the ASCII code for capital H, 101 is lowercase e, and so on. Every number must be between 0 and 255. That's the range of a single byte. See how each method produces the same bytes object, but from different starting points. This is where a lot of beginners get confused, so let's be crystal clear. Strings and bytes look almost identical in Python code, but Python treats them as completely separate types. You cannot mix them directly. If you try to concatenate a bytes object with a string using the plus operator, Python will throw a type error saying it can't concatenate str to bytes. Watch the error appear on screen. This is one of the most common mistakes when learning about bytes. The key takeaway? Always keep strings and bytes separate, and only combine them after converting one to match the other. We'll show you exactly how to do that in the next section. Let's say you want to send a message over the internet. Networks don't understand Python strings. They need raw bytes. So you need to encode your string first. The .encode method is your best friend here. You call it on any string and pass in the encoding format. Almost always UTF-8. Watch as the string good morning transforms into bytes. Notice the type changes from str to bytes. This encoding step is essential whenever you're working with networks, files, or any system that expects binary data instead of Python's high-level string objects. Now, let's go the other direction. You've received some bytes from a server or a file. How do you turn it back into readable text? You decode it using the .decode method. Simple rule to remember. String to bytes is encode, bytes to string is decode. Always use the same encoding for both. If you encode with UTF-8, decode with UTF-8, mismatching them will cause errors or garbled output. Watch as the bytes transform back into a string, and the type changes from bytes back to str. This encode-decode pair is fundamental to working with data in Python. Remember that type error from earlier? Here's how to fix it. You have 2 options. Solution 1. Encode the string before combining it with bytes. This keeps everything as bytes. Solution 2. Decode the bytes first, then combine with the string. This keeps everything as strings. Pick whichever direction makes sense for your program. If you're building a bytes object to send over a network, encode the string. If you're building a message to display to a user, decode the bytes. Both approaches are valid. It depends on what type you need as your final result. One of the most practical uses of bytes is reading files. especially non-text files like images, audio, or PDFs. The key is the RB mode. That's R for read, B for binary. Without it, Python assumes the file is text and might crash or misread it. When you open a file in binary mode and read it, you get back a bytes object containing the raw file data. You can inspect the first few bytes to see the file signature. Those hex values at the start tell you what type of file it is. Always use RB for images, EX for writing binary, and regular R only for text files. Sometimes you need to convert bytes into an actual number. This is common in networking and low-level programming. Use int from Byte to read a number from binary data. You specify the byte order. Big means the most significant byte comes first, like how we write numbers left to right. Going the other way, use into bytes to convert a number back into binary. You specify how many bytes to use and the byte order. This bytes to integer conversion is essential when working with network protocols, file formats, or any system that packs numbers into binary data. Watch how the number 42 becomes 2 bytes, and those same 2 bytes become 42 again. One important thing about bytes, it's immutable, meaning you can't change it after creation. If you try to assign a new value to a specific index, Python will raise a type error. That's where Bytearray comes in. It works just like bytes, but you can modify it. Use Bytearray when you're building up data piece by piece, when you need to modify bytes after creation, or when you're working with buffers or custom network packets. Watch as we change the first byte from lowercase h to uppercase h, something impossible with regular bytes. The Bytearray type gives you the flexibility you need for mutable binary data. Want to see what bytes actually look like in hexadecimal, the format computers love? Use the .hex method. It converts each byte into a 2-digit hex number. You can also pass a separator like a colon to make it more readable. This is super useful for debugging binary data or working with things like color codes, encryption keys, or network packets. Watch how the bytes for the letters H and I become the hex values 68 and 69. Hex representation is your window into the raw binary world. Here's where you'll actually use bytes in your real Python projects. When sending data via a socket, you must encode strings to bytes before sending. When reading images or PDFs, open files in RB mode. When working with APIs, encode the request body as UTF-8 bytes. For cryptography and hashing, pass bytes into the hashing functions. When building network protocols, use Bytearray to construct packets. Watch this socket example. Notice how we encode the HTTP request before sending it. Bytes are everywhere in Python, from networking to file handling to security. Understanding them opens up a whole new world of programming. Here's your quick reference cheat sheet for everything we covered. Create bytes with the B prefix, the bytes constructor, or a list of integers. Use .encode to turn strings into bytes, and .decode to go back. Use Bytearray when you need mutable bytes. Convert between bytes and integers with from bytes and to bytes. Inspect raw values with .hex. And always use RB mode for binary files. Keep this reference handy. It covers all the essential bytes operations you'll use in your Python projects. Each section highlights as we go through it, so pause if you need to take notes. You've just mastered Python Bytes. You now understand what bytes are, how to create them, how to convert between strings and bytes, and where to use them in real projects. Bytes might seem intimidating at first, but once you get comfortable with them, a whole new world of Python programming opens up. Networking, file handling, cryptography, and more. If this tutorial helped you, please like and subscribe for more Python content. Keep practicing, and you'll be a Bytes pro in no time. Happy coding!